Welcome back to The Explainer. Today we're embarking on a purely educational, completely vendor-neutral deep dive into a topic that literally runs our modern digital lives, yet somehow still remains a bit of a mystery for a lot of people. We're decoding cloud computing and cloud storage. Let's cut through all that heavy industry jargon together and get a crystal clear, concrete understanding of what the cloud actually is, how it works, and why it's the absolute backbone of today's internet. Let's demystify the magic behind the screen, shall we?
Okay, let's dive into this macro to micro journey. First, what is cloud computing? Second, why is the cloud essential? Third, who actually uses it? Fourth, we'll look at the major cloud providers. And finally, number 5, we'll be decoding cloud storage.
All right, Section 1. What is cloud computing?
We hear the phrase the cloud tossed around so often that it can honestly start to feel like this abstract, formless concept, like it's just floating up there. But the reality, it is highly physical, incredibly structured, and purposely engineered. When we talk about the cloud, what we're really talking about is a massively scaled, globally distributed network of servers and virtual machines. It's not just one giant, dusty warehouse of computers sitting out in a single remote desert. It's this highly interconnected web of computing power, databases, and network services that are intentionally placed physically closer to end users. So whether you're sitting in Tokyo, London, or New York, the whole architecture is designed so that the digital resources you request don't have to travel halfway across the globe to reach your device.
And this brilliantly illustrates the massive paradigm shift we've experienced over the last 2 decades. I mean, think about the old way. It forced companies to buy, house, and power their own expensive on-premise hardware. If you wanted to start a digital business back then, you needed a literal freezing cold server room acting as a single centralized core data center. The cloud way flips this completely on its head. Now businesses just tap into a distributed global network. They rent computing power, databases, and security strictly on demand. It's a universal grid, and it's accessible instantly from anywhere.
Moving right along to Section 2, why the cloud is essential.
So we really have to ask the why here. Why did virtually the entire tech industry and subsequently the entire global economy abandon local servers in favor of this distributed model? Well, the answer comes down to some undeniably powerful business advantages. Basically, there are 3 core pillars of the cloud advantage. First is massive scalability. Second is ultra-low latency, and third is severely reduced capital expenditure, which you'll often hear abbreviated as CapEx. Now, these aren't just corporate buzzwords, they represent a fundamental transformation in how businesses operate, how they manage risk, and how they deliver digital experiences to you and me. Let's actually break down how this works in practice.
Think about how the cloud solves real, tangible problems. Step 1, scalability. This means you can handle totally unpredictable traffic spikes seamlessly. Say an e-commerce site suddenly goes viral. The cloud automatically allocates more servers to handle that massive load, preventing a total site crash. Step 2. Because the cloud is globally distributed, it intelligently routes data around internet congestion. That ensures ultra-low latency. Put simply, it means the pages and videos you and I browse every single day load instantly. Step 3. It completely eliminates what the IT industry calls forklift upgrades. You literally no longer need to forklift old, expensive hardware out of your building just to replace it with new servers. Instead, companies get to enjoy flat, predictable pricing, literally paying only for the computing power they actually use. It's a game changer.
Next up, Section 3. Who uses the cloud?
So who exactly is benefiting from all this infrastructure? It's a pretty common misconception that cloud computing is strictly for Silicon Valley tech giants. Today, the cloud is the silent engine powering the entire modern economy. Basically, everyone relies on this. Fortune 500 enterprises use it to manage complex global operations. E-commerce leaders use it for heavy, decision-intensive transactions. Major media companies rely on it for ultra-low latency live video streaming. Top financial institutions use it for incredibly secure, rapid data processing. And independent developers? They use it to build the next big app from their bedrooms. For example, when you play a multiplayer video game, cloud computing is the thing doing the real-time matchmaking. When you're playing around with a new AI tool, all that heavy lifting, known as AI inferencing, that's being processed on massive cloud GPUs, not on your local phone or laptop. Which brings us to Section 4, the major cloud providers. Now that we know what it is and who uses it, let's identify the heavyweights. We're going to look at the major industry players, commonly referred to as the hyperscalers, simply because of the sheer unprecedented size of their global networks. 2 of the most prominent hyperscalers powering massive enterprise workloads today are Alphabet's Google Cloud Platform and Microsoft Azure. Both of these absolute giants offer a vast array of services, spanning from basic web hosting all the way to incredibly complex artificial intelligence and machine learning environments. They've strategically placed massive data centers all over the world, which allows companies to integrate deeply into their respective ecosystems.
And of course, you cannot talk about cloud computing without talking about Amazon Web Services, or AWS. AWS is an absolute titan in the market. They were a true pioneer in bringing on-demand cloud infrastructure to the masses. Now, while AWS and the other hyperscalers offer incredible scale, they do have a characteristic you really should be aware of: data egress fees. Egress fees are basically the costs associated with moving your data out of a provider's cloud. And sometimes these fees can be quite high. This can effectively lock a customer into a single provider's ecosystem, just because it becomes simply too expensive to move their data anywhere else.
Because of things exactly like egress fees and the widespread desire to avoid that vendor lock-in, the industry has rapidly shifted toward what we call a multi-cloud strategy. This brings players like Alibaba Cloud, Oracle, and others right to the forefront. A multi-cloud strategy basically means a business might use AWS for one specific task, Oracle for their databases, and maybe another provider entirely for global content delivery. This allows businesses to maintain maximum flexibility, optimize their performance, and keep their infrastructure costs in check. For sure, the future of the cloud is undoubtedly a diverse multi-cloud ecosystem.
And finally, Section 5, Decoding Cloud Storage. Let's move to and see how this builds into our final segment. We've talked a lot about the macro network, but now we're doing a micro-level deep dive. How is data, from your family photos to massive enterprise databases, actually kept and managed within these sprawling networks? Well, the first major type to understand is object storage. Think of object storage as a massive, highly resilient digital warehouse where data is kept as distinct units or objects. It is incredibly flexible, allowing developers to store large volumes of unstructured data types, things like strings, arrays, lists, or nested JSON files. And because it's highly available and distributed across multiple regions, if one server happens to go down, your data is still perfectly safe and instantly accessible from another.
Next up, we have block storage. If object storage is that flexible digital warehouse, block storage is the traditional heavy-duty hard drive in the cloud. It provides raw storage volumes that act exactly like a local drive attached to a physical computer, making it the fundamental mechanism for running core applications and operating systems on virtual machines. It is highly performant, incredibly robust, and totally essential for traditional, intensive workloads.
So, the crucial point is, managing all of this data manually can be incredibly complex. It's a headache. That's exactly where managed databases, or database as a service, come in. This offers what we call as-a-service ergonomics. Instead of an enterprise needing to hire a specialized database administrator and just hoping they don't tear their hair out installing, configuring, and maintaining all that database software, managed databases allow software developers to invoke complex database functions with literally just 1 or 2 lines of code. The cloud provider handles all the scaling, the backups, and the maintenance entirely behind the scenes.
Which really brings us to the absolute frontier of this incredible technology. As cloud infrastructure continues to push out from centralized data centers and moves even closer to the edge of the internet, meaning physically right next to the user, we have to ask ourselves, how will this new era of ultra-low latencies transform the next generation of global applications? Will it be seamless augmented reality, instant global financial markets, or things we haven't even dreamed up yet? The foundation is laid, and the cloud is ready for whatever comes next. Thank you so much for joining me on The Explainer today, and keep learning.